Hello, this is Maths with Lemon, and in this topic we will see the arcs, sectors, and segments of circles. Let's see one by one what is it and what describes basically. Sector. A sector is the area between two radii of the circle. The minor sector is the smaller of the two sectors, shown with the yellow here, and the major is the larger one of the two sectors. Arc. An arc is a section of the circumference. The minor arc is the smaller of the two arcs, shown in the orange, and the major is the blue. A chord. A chord is a line whose two endpoints, here and here, lie on the circumference. The diameter is the longest chord on the circle. And last, a segment is the section of a circle produced by dividing it with a chord. Now, this circle has a radius of 4 centimeters. The sector has an angle of 60 degrees. Find the area of the minor sector, and then find the length of the minor arc. Let's see that. This sector is a fraction of the whole circle. What fraction is it? The sector takes up 60 degrees out of the 36, which is the whole entire circle, or 60 out of 360 of the circle. This means that the sector contains this fraction of the total area and circumference of the circle. The area of the circle is pi times r squared, which is 16 pi. For now, we leave pi in this area because it is more accurate than using a rounded off decimal. The area of the sector will be the part that the sector of the circle is, so 60 over 360 degrees times 16 pi, which is 8.38 centimeters squared. The circumference of the whole circle is 2 pi r, so it's 8 pi. So the length of the arc will be again the fraction of the whole, the fraction of the sector, which is 60 over 360 degrees. So it's 4.19 centimeters. Now, this circle has a radius of 5 centimeters. The sector has an angle of 280 degrees. Find the area of the major sector and find the length of the major arc. It's the same problem. Again, this sector is a fraction of the whole circle. How much is it? It will be 280 over 360 degrees, which is 7 over 9. Again, this means the major sector contains this fraction of the total area and the circumference. The area of the circle is pi times r squared, 25 pi. And again, the area of the sector will be 7 over 9 times my whole area, which is 175 over 9 pi square centimeter square. The circumference of the whole circle is 10 pi. So again, the length of the arc will be the fraction of that, which is 70 over 9 pi centimeters. Now, the sector has an angle of 35 degrees. The arc length is 20 centimeters. Find the radius of the circle which this sector came from. Now we have the opposite problem. Let's break it down into some steps. First, find the circumference of the whole circle. Then use this to work out the radius. So the sector takes up 35 out of the 360 that it's the whole circle. If 35 gives an arc of 20, 1 degree must give an arc length of 20 over 35. Therefore, 360 degrees will give a length of 360 times 20 over 35, which is the circumference. So the circumference is 205. Now, if the circumference is 205.714, then I can find r, which is over 2 pi, 32.7 centimeters. Now, here with the segment. Here is the segment of the circle. Find the area of the segment. This is a very common problem. What should I do is, first, I need to work out the area of the sector, and then take away the area of the triangle, and I will find the area of the segment. So the sector has 80 over 360, since it's 80 degrees, 80 over 360 times pi times r squared, which is that, 17.453. Now find the area of the triangle. To find the area of the triangle, I need to use the sine rule. I know this side, I know this side, and I have the angle. So basically the area will be 1 over 2 times A times B times the sine C. And the answer is 12.310 centimeters squared, the area of the triangle. Now if I will remove the area from the area of the sector minus the area of the triangle, I will find the area of the segment. Let's see also this problem. Here is a segment of a circle with a radius 5 centimeters. The chord that makes the segment is 8 meters long. Find the area of the segment. Again, we can find the area by subtracting the area of the triangle from the area of the sector. Now, however, we first need to calculate the angle A and the height of the triangle. Basically, there is another way, but let's see also this way. Use the Pythagoras to find the height. I know that this is 8, so the height is going to be exactly in the middle. Why? Because this is an isosceles triangle. So the height divides basically the base into 2 equal parts. So if this is 5, the radius, this side will be 4 centimeters. So the height is going to be 5 square minus 4 square using the Pythagoras. So the height is 3. Now I can find my angle B in this triangle. I can use sine, which is opposite over hypotenuse, and then the inverse to find the angle. So the angle is 53.13, angle B. So how much is going to be A? 2 times that. So 106.26 degrees. Now I can calculate the area of the sector. The area of the sector will be 106 degrees over 360 of the circle times pi times r squared, which is 23.182. The triangle, it's base times height over 2, which is 12 centimeters squared. And the area of the segment will be, if I'll remove from the sector, the area of the triangle.